Welcome to my presentation. In this presentation, we shall see how to represent improper fractions. So, let me illustrate this with an example. I want to be able to explain this improper fraction concept in a slightly different manner. Let me take a box. Let me draw a figure here. This is a square, and I'm going to draw another square, and I'm going to divide these squares into four equal parts. Part 1, 2, 3, and 4. 1, 2, 3, and 4. Now I'm going to shade all the four parts in the first block, and I'm going to shade just one part of the second block. As step number one, I'm going to say in the first block there are four parts are shaded out of the four parts which are available to us, or out of the total of four parts. Plus, in the second figure, one part is shaded out of the total of four parts. So therefore, in my second step, we can come back and then say, since the denominator is the same, we're going to write the denominator once, and we're going to add the numerator parts. 4 plus 1, which is going to be equal to 5 divided by 4. That is how we're going to represent that. And in step number 3, we're going to now make a decision. Since the numerator NR is represented as numerator, since the numerator number value is greater than the denominator value, therefore this is a improper fraction, as we're going to come back and then call this as a improper fraction. Improper fraction. Whenever the value in the numerator is larger than the value in the denominator, we call it as a improper fraction. 5 is larger than 4, therefore we're going to call it as an improper fraction. Let me take another example and then illustrate this point. In this example, I'm going to illustrate this improper fraction concept in terms of in terms of a figure like this. I'm going to draw a rectangle. A rectangle has two long sides and two short sides. I'm going to draw three of them like this, three boxes like that, and make it into four parts. Make it into four parts like that, each of these blocks. This is part 1, 2, 3, and 4. Part 1, 2, 3, and 4. Part 1, 2, 3, and 4 for the third block as well. Now, I'm going to shade the first block completely like this. I'm going to shade it completely like that. I'm going to come back and then shade the second block as well completely, and I'm going to shade three parts of the third block like that. I'm not going to shade the fourth part. So now, as step number one, we're going to say there are four parts which are shaded out of the total of four parts in the first block, plus there are four parts which are shaded in the second block of a total of four blocks, plus there are three parts which are shaded out of the total of four parts in the third block. So as a second step, I'm going to come back and then say the denominator for these three fractions are the same, so I'm going to write the denominator once, and I'm going to add the numerators. 4 plus 3. 4 for the first block, 4 for the second block, and 3 for the third block. So I write the common denominator once and I add the numerator parts. 4 plus 4 is 8, 8 plus 3 is 11. So therefore, when we put all of these things together, the fraction came out as 11 over 4. As we can see, 11 is greater than 4, where we said if the numerator is larger than the denominator, then it is a improper fraction. As step number 3, we're going to then call it as since the numerator is represented as nr, is greater than the denominator, which is represented as dr. Since the numerator value is greater than the denominator value, therefore we're going to conclude that this is a improper fraction. This is an improper fraction. Sometimes it is a lot easier to be able to draw a figure and then make sure the number of parts shaded in that region, and add them up, and then make a decision based on the value we have in the numerator and the value we have in the denominator. If the value in the numerator is larger than the value in the denominator, then we call it as an improper fraction. In my next presentation, we shall see how to represent some more improper fraction problems.